So the module we'll look at in the class is we'll look at the pick and place station. And this is module 1. And the video is not going to play. A recorded lecture? Yeah, correct. Okay. So this is a video of the module if it runs. So notice what happens is it comes up to the place robot, moves over, and then sets it down on the carrier. It's a pretty simple process. So it's all taking place. The valve is kind of rotating. Oh, you mean this guy right here? No, don't rotate around. No. No, it picks it up, picks it straight up. Then, of course, it traverses. Of course, I don't mean it does. It's just that I don't remember it doing that. Control line, module 1. Now, ours is a little different than theirs. Yeah, I didn't rotate. They're just looking at it from a different angle. It didn't rotate. It moved. I don't know if those are videos up there or not. Well, I wouldn't put them up there now because another thing I realized about putting the videos up there is that it takes forever to copy the course over. It took all night to copy the course over, so that's why another reason I went with the links. So I'd have to upload those to YouTube, and I don't know if we got the rights to do that. So what's the sequence? How does this thing work? Yeah, on the hopper or the magazine or whatever you want to call it, the bottom indicates there's a block present. And then what are we waiting on? Oh, yeah. No, it's waiting on something else now. What's it telling? It's waiting on what button on the front? So let's go over a table that shows us the sequences that we go through, right? So here's the sensors. So first thing, you need to know the sensors. So this is B1. It doesn't have a 1 in front of it because it doesn't belong to an actuator. So 1B1 is this. This is a Hall effect. 1B2 is here. Right? You understand that? Are we okay? Of course, this is 1D2, which is a one-direction flow control valve. And this is 1D1. This is 1A1 because this is the actuator. And this is the rest of it. So here's the vacuum. They don't show us our pressure sensor, flow control valve, but the ones on here, there's 1B1, I'm sorry, 3B1 and 3B2, and it says these are Hall effect. And this is some of these are wrong, by the way. This is not a Hall effect. This is a re-switch. So when they documented this, they got some of the things wrong. And they don't show the Hall effect on this side. What's the Hall effect on that side? We'll look at that in a minute. So we went over those. Are we okay here? Other class. We went over the electrical symbols. Are we okay there? Anybody got any questions here? Okay, went over that last class, right? Talked about the PLC outputs. Are we okay here? Everybody okay here? Then I think we looked at the pneumatics. These are the terminal blocks, by the way. We don't need to look at those right now. This is probably a little better. This tells us all the sensors, but it don't show us their location. So that first picture shows us our locations. Here's the pneumatic symbols, and this is what we want to look at right here. This is called a function chart. So at the front, up at the top, by the way, the little up caret right there. Let's see what I'm talking about. If I can. All right, here. This is a logic AND. So what it means is all three of these conditions have to be true before we do anything. So this says 4B1 has to be true. B1 has to be true. So we're not sure about 4B1, so we need to find out where that guy's at. So 4B1 has to be true, and B1, which is the part sensor, and I have to do what? I have to press the start button. Okay, so if that's true and I press the start button, then what's going to happen? Cylinder 1A is going to extend, and that's the output on our PLC. And when it extended, what is it going to occur? It's going to do what? It's going to change 1B2. Now, what's going to be required by my next step? So to go to this next step, it's looking for what? 1B2 to be true. Now, if 1B2 is true, then Q4.6 on .6 output of the PLC is going to go true, which should do what? Extend the pickup cylinder, which is going to cause what? 3B2 to go true. Now, if 3B2 is true, see, so this is what sensor this is going to affect. This is what's required to go to the next step. That makes sense. So here, if 3B2 is true, then what's it going to do? It's going to turn on the what? The vacuum generator is going to turn on, which is going to cause my pressure switch 2P1 to do what? Become true. What's that? This is called a function chart. Now, some people might have a quite different name, but that's what we'll refer to it, the function chart. And this is what y'all are going to try to develop tonight for your section of the line, for your module. Now, if the pressure switch, if it says we've got a vacuum because the pressure switch goes true, then if the pressure switch is true, what's the next thing it's going to do? It's going to retract that feed cylinder, right? Which is going to cause what? 1B1 to go true. Now, if 1B1 is true down here, that's going to do what? Retract the pickup cylinder. That's the guy, and it's going to retract it, right? Which is going to affect what? 3B1, which is at the top of that cylinder, right? Y'all follow me so far? Okay. If that's true, then what's it going to do? It's going to extend the traverse cylinder, which is actuator force, and it's going to affect what? 4B2. If 4B2 is okay, then it's going to extend the pickup cylinder again, which is going to move the block down, right? And it's going to affect that sensor right there. If 1B2 is true, then the vacuum generator is going to turn off, and it's going to look to see if 2P1 is turned off. Right? You understand? Here, if 2B1 is turned off, then what's it going to do? It's going to track the pickup cylinder. It's going to affect 3B1. If 3B1 is true, it's going to do what? It's going to retract the traverse cylinder, which is going to back, and there's where 4B1 comes through. So 4B1 says the traverse, so we looked at it, but we just didn't call it that number, right? You understand? So 4B1, and then what do we do? We're ready to do the whole thing again, right? You understand? And this is called a function chart. Yeah, it's simple when somebody does it, but it's up to you to figure out how your section works, right? Y'all understand that? And of course, you need to understand what sensors. So you need to see, okay, what sensors are true and what sensors are false. And then, of course, we'll figure out which way to go with this, right? You understand? And you might be right or you might be wrong. It doesn't hurt to be wrong. It's great if you're right. It'll give you a feel of setting up vacuum, setting up function charts. Are we okay? Huh? Well, because you might miss a sensor, so it might require a sensor that you don't see to start it. Or there might be more than one sensor. We can look at some of these function charts, and it will be more than one sensor that looks at it, especially on the conveyor belt. So the conveyor belt goes different ways depending on whether it's an acrylic block or whether it's a metal block. So we'll look at that function chart. We're going to do the function chart on the second and the third. So somebody's going to do it on the carousel, and then one group's going to do it on the other one. So modules 2 and 3. The module 4 is a little different because it's got conditions. It runs different sections in the function chart depending on what conditions met. So if it's a metal block, it does one thing. If it's an acrylic block, it does another. So we'll see how that works. And it depends on multiple sensors. This is pretty easy. That's what we're looking at now because we're only looking at one sensor. And it's pretty easy that what this affects is the next that's required to move on to the next block. By the way, I forgot what they call the language, but the new Siemens software, you can program this into the PLC. You program this function chart into the PLC, which is really neat. So if you set up this function chart, you don't have to put normally open contacts, normally closed contacts. You basically use these tags. Well, I'm sorry, you can use these tags. I think Alan Bradley calls them, I can't remember. Siemens calls them tags. So what you can do on the Siemens PLC is you can assign a output a name. And then instead of, you can do that on the Allen Bradley PLC too, if y'all did intro to PLCs. Once you've assigned a name, then you can enter the name and it automatically assigns it to the coil. And Allen Bradley, Siemens calls those tags. So right here, if we gave Q4, Q4.5, which is, so this is so Siemens is what? So Q is what? Output. And then this is the what? This is the module group. And Siemens moves in groups of fours. Groups of eights. And then they put a dot. And then they put what we call the bit number. So it's pretty close to the Allen Bradley. I can't remember what Siemens used for a word, but so the Allen Bradleys use a dot for a word, and they use a slash for a bit. The Siemens use a dot for a bit, and I'd have to go back and look at it and see. I'm new to the Siemens PLC too, so now the next chart that's available is what we call a step chart. So a step chart, notice we got how many steps? We got 11 steps, right? You understand? Because the last step is to do what? Oh, I'm sorry. 0 through 10. Well, 0 is the start position, which will be what they're calling 1. So what we do here is we put our different actuators. So we got our actuators. So on this guy, we got 4 actuators, right? You understand? So they're off on the left. And then what can we do with those actuators? Well, our cylinders, we can do what? We can extend or what? Retract. The vacuum, we're going to do what? Turn it on or off. So to start it, what does it say we need? It says we need what? Now up here, these are the steps. So first of all, before you set up your chart, you need to count the number of what? Steps. That makes sense? Okay. And then what you need to do is over here on each cylinder, you need to put down what position these sensors are in. That makes sense? So what do we need to start it? 1B1 has to be what? True. 2P2 has to be, it has to be off, right? 3B1 has to be what? Retracted. And then 4A, which should be 4B1, has to be what? Attracted. So that's how it starts. Then we come over to the next step. So what happens? Well, the feed cylinder does what? Extends. And what does it affect? 1B2. Right? You understand? Everybody okay? Any questions? What happens but what else happens in step 2? So, no. So this is going from step 1 to step 2. That's what I should. So what else happens in step 2? Nothing. Right? You understand that? Yes or no? Okay. Then here's step 3. What happens to the part cylinder, step 3? Nothing. It stays what? Stays extended, right? You understand? Okay. What happens to the vacuum? It's still what? Not yet. It don't turn on until here. It's still what? Off. So don't get this confused with this right here. Right? You understand? So pickup cylinder 3A extends. Right? You understand that? Then what happens to the driver cylinder? It's still retracted, right? You understand? Yes or no? Okay, so what happens at step 4? Stays the same, right? Okay. What happens to the pressure switch? It cuts on, right? See? You okay? What happens to the pickup cylinder? Stays extended, right? And then what happens to the traverse cylinder? Stays retracted. Now, anytime you have a change, it's going to affect the what? Sensor, right? You understand that? Yes or no? So when we had this change right here, it affected what? 3B2. Okay, so what happens on step 5? It's going to do what? It's going to track, which is going to affect what? 1B1. And then it says, okay, 1B1 caused what to happen? It caused what? Nothing yet, right? Are we okay? But it, huh? 1B1 went true, okay, which comes over here and says, okay, at this point right here, what? 1B1 is also true, right? Okay. I'm sorry, 1B1. Go ahead, James. I guess I should be doing this in another color besides for the color that the lines are in. So this is what kind of gets some people, okay. So what's fixing to happen when it goes to step 6 is this guy right here is going to do what? Retract. Well, what let it know it could retract? 1B1 was true, right? So when this sensor right here went true, then whatever changes on the next step was caused by what? 1B1. Okay, y'all understand? Yeah. Yeah, so whatever happens on the next step had to happen because of something. Well, what had happened is that when this guy hit here, it came over here and triggered what? 1B1. So that's what they're doing. This little old crooked line over here, they're saying it's going to cause to trigger the next step, right? That makes sense? Oh, okay. So what happens in step 6? The part cylinder stays what? Retracted. The vacuum grip stays what? On, right? You understand. This guy is going to do what? Retract, which is going to trigger 3B1. Now 3B1 is going to affect something. What's it going to affect? It's going to set up for step 7. That makes sense? Okay. So here comes step 7. What happens during step 7? Part cylinder is still what? Yeah, retracted. The vacuum is what? Still on, right? You understand. Okay. Where does 4B2 come on? Oh, I'm sorry. We ain't there yet. Okay, so what happens here? So the traverse cylinder does what? No, the traverse cylinder does what? Extends. Okay, y'all okay? Traverse cylinder extend, right? Or if it was in automatic mode, it would cause it to extend. But when we have it on manual mode, between every one of these, we're doing what? Pressing the start, right? So we don't put the start button on these. So this step chart is not set up for manual mode. It's set up for what? Auto. Everybody understand? So since 3B1 was set, it causes the traverse cylinder to extend. Okay. And then we come up here and do what? Then 4B2 affects this. So what happens here? Well, when this extended, then that's through with step 7. This is going to cause 4B2 to go true. Step 8, what happens? One A1 stays what? Retracted. The vacuum gripper stays what? On, right? 3B, this stays extended right now. This is going to change. So what happened is your pickup cylinder did what? It extended, right? Everybody okay? Which triggered what? 3B2, which is going to trigger step 9, right? You understand that? Go ahead, Barry. Okay, so we're looking at step 7. What happened during step 7? Well, 4B2 is a sensor. So sensors don't retract or extend. Sensors indicate it happened. So what happened in step 8 is that cylinder 4A extended, which caused 4B2 to go true. Okay. Right, you understand? Now we're through with step 7. Now we're ready to move what? To step 8. Now when 4B2 became true, what happened to get to step 8? There's only one thing. If we follow this down, what happens in step 8? Part cylinder stays what? It's still retracted. The vacuum is still on, right? You understand that. But this changed. So 3A did what? 3A extended, which triggered 4B2. But that's all that happened in this step. Okay. Now, what this arrow is showing you, this shows you what effects that extending 4B2, triggering 4B2 has, right? You understand? So we move to this step right here. Now, what happens in this step? Well, the part cylinder is still what? Retracted. So what happened between step 8 and step 9? Well, the vacuum grip turned off, which causes 2B2, to turn off, really, right? You understand? 2P1, which is going to affect this guy right here. And then what else happens? Well, that's all happens in step 9. Well, what happens in step 10? Pickup cylinder retracts, which triggers what? 3B1. And then what happens in step 11? It's traversed, and it noticed this and this had better what? Said they had better match. Y'all understand? So like represents 10, so 3B1 represents that. What's that? 2P1. Okay. So the extend cylinder is looking for 2P1 to become true. 2P1 became true in what step? Step 9. Now they show this arrow shows, okay, what does 2P1 do? Well, 2P1 tells the pickup cylinder to do what? Retract in step 10. Okay, understand, James? Okay. So what we're saying is okay, and this is what gets people confused. They're trying to move to the next step. So what happens during step 2? What happens in step 2? Extends. What else happens in step 2? Nothing. Except for 2B1. 1B2. Yeah. In this step chart, is that always true? No. So you can see multiple things happening at the same time. I don't know if we can on the amateur line. I'm trying to think. This is what we call a step chart of steps. Yeah. It's just that this step here is this step right here. Huh? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Huh? Are we okay? So basically on the function chart, here's 1. And down here is what? Is 11. Right? That's on the, if I, and then this would be 2 on the SHEP chart, 3, 4, 5, 6, 7, 8, 9. Yeah. No, 1's okay. This is 1. So 1's okay. This 0 right here really means nothing. So this is actually 1. It's just down here on 11. What is 11? Well, 11 is this guy right here, which sets us up to go back to what? Or the start. So I think that's what they're saying. 11 equals what? 1. So on the function chart, they just don't give this step right here a number. But 11 and 1 are the same, right? So the step chart, what we need to make sure on the step chart is that this last step had better be, it's going to always be what? The first step. Because that's when the automated machine has made its cycle. Right. So what we do here is we basically go over there and say, okay, what sensors are true? Now, the one that we messed out on was this guy right here, but I said it because what's the initial start position on that one? Well, the traverse, what they call the traverse cylinder, has to be retracted or on the left, right? Understand that. What else had to be true? Part sensor had to be there, which was D1. What else had to be true? The parts feeder cylinder had to be retracted, right? Which was, I believe, it was 1V1. And then the pressure was what? Off. Now, of course, on the function chart, the pressure off is, they don't even show that. Now, whether that's true or not. I don't know if it I don't know if it monitors that sensor. We would have to look at the PLC program itself, but there's a fact that nothing happens if the pressure, we know for a fact that nothing happens if the pressure's off. But I think that was probably because of this right here. 1B2 would never go true. If 1B2 never went true, then nothing else happened, right? The KUKA robot has a sensor on the pressure. So if you're working on a KUKA robot, if you don't have pressure on, you can't do nothing. All the other robots, they don't care. They don't monitor the pressure. So we understand there's an open loop and closed loop, right? So, and what advantage does open loop have over closed loop? Cheaper. Yeah. So we depend on, and it doesn't mean it's not accurate. It's just that we're going to depend on mechanics, right? You understand? Like an actuator stroke, or we might depend on mechanical stops. So open loop can be very accurate, and it can have a high degree of repeatability. But the problem is it's not flexible, right? You understand what we're saying? So I think it was kind of wrong saying that closed loop is more precise, because open loop can be extremely precise. It's just that we don't know if something don't happen. The controller doesn't know if something don't happen. Flexible would probably be the better term. No, because we teach that in robotics. There's some robots out there that are open loop. To be a robot, you have to be programmable. But programmable doesn't necessarily mean software. Programmable means you just need to be able to change what it does. So you could go out there and move an in stop, and that would, you would be doing what you would be reprogramming the robot. So step charts. Ever got any questions on step charts? Yeah, when you try to do it yourself. And like I said, we're going to split up in groups. Well, they could, and I've seen some people come down here and just they'll come down and do that. They'll just put 1B1 down there too. You could do that because what caused this right here to move was 1B1. Now, what Siemens did when they did the step charts is I don't think it was even Siemens. I think Amatrol did this. When they did the step charts, they decided to only put the sensor that triggers an event where it is triggered, and then what it triggers, they use those lines. So you could do like this if you wanted to. All we're trying to do is figure out, or you can do what I just did. So what I just did is I just came over here and said what, and it's all up to. I just came down here and put 1B1 right there. It makes sense. Well, yeah, but you don't want to get confused about this triggering 1B1 because this isn't what triggered 1B1. This right here is what triggered it. So probably the best method, those squiggly lines are okay, but you could also just do what, James? You could just come down here and just put it in there. All you're trying to do is saying, okay, 1B1 went true because what? 1B1 went true because this part cylinder was retracted. And then we would need to say, okay, what effect did 1B1 going true go? Well, 1B1 caused what? It caused the pickup cylinder to do what? To retract. Understand? Yes or no? So the way they're doing, they're not putting what they're saying, okay, what caused the sensor to go true? Well, what caused the sensor to go true was 1A did what? Retracted. Well, what effect did 1B1 have? Well, 1B1 affected this right here. So 1B1 didn't trigger. So 1B1 did not trigger the sensor. This did not trigger the sensor, but this uses the sensor to decide to do what? For it to decide to retract. So the little squiggly lines are okay, but if you just want to draw arrows, that's fine. You know what I'm saying? Yes or no? Well, somebody would say, well, this caused that sensor to go true, but it didn't cause that sensor to go true. What caused the sensor to go true was what? So what effect, what does 1B1 monitor? Well, 1B1 monitors if what? 1A is what? Retracted. That's what 1B1 does. So 1B1 is a sensor that indicates that 1A is what? Retracted. Now, what effect does 1B1 have? Well, 1B1 affects this right here. So that's what they're doing. They're putting these arrows, saying, okay, well, what did 1B1 affect? Well, 1B1 allowed cylinder 3A to do what? Retract, and I'll go into step 6. Now, only having one thing per step, it all depends on the process, right? Understand? So I might extend the cylinder and turn on a lamp. Well, now what we've got is two things that occur because of 1B1. Okay, yeah. So everything that occurs with that, from that sensor being true, would be what happens on the next step. Are we okay? Well, what you're going to do is you're going to go over there and look at all your sensors, right? So what we'll probably do is I'll go have to run them off. Is I'll probably give you this right here, which shows you the sensors, and in that way you know what sensors to look for, right? And then you'll determine if they're what, true or false. And how do we know if they're true or false? Yeah, there's an indicator lamp on all our sensors over there that indicates when they're true or false. So you'll, before you start, you'll go out there and do what? Okay, this sensor's true. This is true. This is true. Right? You understand? So the first thing you got to do is figure out what actuators are on the line. What actuators are on your module. Go ahead, Corey. What does P stand for? That's a pressure switch. There is one sensor missing on this, and that's the traverse retracted. And what's the traverse retracted? Feed cylinder, pickup cylinder. Vacuum on. So the traverse retracted is so the traverse retracted is 4B1. So 4B1, you don't show that, right? Because 4B1 is right in here. I'll have to. Of course, y'all not going to do this line right here, this section right here. So I'll print off these, which shows you the location of the actuators and also the locations of the sensors. Not the actual location, but what the sensors are called. Anything else? Yes or no? Questions? Keep those out, Thomas.